The future is here already. It's just not evenly distributed. Yet. Today's world teems with innovation. The nexus of hardware, software, and human ingenuity promises a revolution in possibilities. What does tomorrow look like? Witness Future Proof.
All right, ladies and gentlemen, welcome back once again to Future Proof. Your host here, Eric Kavanagh. Today, we're going to be talking about one of the significant challenges in the world of data management, and that's bad data. Really bad files is what we're talking about today. So if you've ever been a data scientist or worked in the data science field, if you've worked in data management, you know that you're trying to load data files into various technologies to understand what they mean. Well, sometimes the data just doesn't load. Sometimes you get a file that's bad and it causes you trouble. Well, it turns out there are lots of tricks to the trade that some folks have learned over the years. Today, we're going to learn from Dr. Jeffrey Malofsky, inventor of DataStar, datastarng.com, who's going to help us understand how a particular kind of technology uses scale-out architecture and lots of useful tidbits developed in a library over time by Dr. Malofsky. So Dr. M, as I call him, the fix-it guy, he fixes data systems, information systems. He's going to show us today his new technology, how it's evolved, and how it can help companies really get over a significant hurdle out there, which is when files won't load. It's the bad data challenge, solving for success with Dr. Jeffrey Malofsky. Here we go. All right, Dr. M, take it away.
All right, thank you very much. I am just going to get the display going, and that should be going. So hopefully, give me a thumbs up, everyone can see it. So just a few comments. I very much appreciate the introduction, and then I'll make a few comments about science. And Eric, as usual, is very astute in his commentary. So my former science life is I was a basic research scientist at the Naval Research Laboratory, doing what is called nanotechnology from the side. So what I did was basic science and then what's called the applied science as well, in which you take the very basic understanding and then you try to make something useful out of it. So in the research that I would do is I had this very large ultra high vacuum piece of stainless steel equipment. And because it was ultra high vacuum, part of the tediousness of it was cleaning the internal surfaces ad nauseum. So there were work weeks where I spent the entire 40 hours, actually more like 50 or 60, just cleaning. That's it, just cleaning. So the point is that yes, to get the good result in a complicated environment can be very tedious. That leads to the characteristic that you need to have of persistence. The other one is that you have to expect the unexpected. That's the whole point of either the science side or the engineering side. On the science side, you're trying to discover something. On the engineering side, it's even more critical because that's how you try to stop errors. And there's such a field as error propagation. So error propagation generally means like if you had a data file and that gets written to disk for sake of argument, and then something happens that there's a couple of characters out of whack or whatever, then that small number of errors propagates as you continue to use the data. And generally, the growth in the error rate is exponential. Now, that's true of a science result. If you ever had the misfortune, like a lot of first-year graduate students do, being irrationally exuberant that they're doing such great work, and then you give your thesis advisor those results, and he rips it up and throws it back in your face. That's one of those watershed moments in graduate school where it's like, well, I guess I have more to learn. So in data science, it's exactly the same thing. Data science uses a lot of cool functions and tools, but it is not just about doing R, doing Python, getting stats. You can't do any of that until you've done the tedious work. Most people don't like to do the tedious work, which is why you still see error rates that are extremely high in almost all corporate environments. I put the phrase almost all in there. The truth is, in the hundreds of corporate and government environments I've seen, and I'm talking large scale data systems, either the major authoritative data sets for accounting or marketing, customer relations, supply chain, ERPs. They're riddled with errors, just riddled. And so you have to get down to them. All right, so then that gets to the next side of what we're going to do about it. So we've lived this problem many times. The good news is we have successfully solved 100% of every problem that we come across. That's basically due to persistence and really understanding. So when you expect the unexpected, one of the ways you do that is you have to actually think like your subject. And that may sound a little odd to people, particularly business analysts, but a lot of the times you have to really understand what's going on. You have to understand where it's possible for something to go wrong. And in data science, that means, what is the file structure? How is the data being moved onto the disk? How is the operating system controlling the characters? If you move it across platforms, do you in fact have different encoding systems that could modify it? Has somebody in your work stream, without telling anybody, gone ahead and loaded it into Microsoft Excel and done some analysis and then exported it and sent it on its way? Has a data engineer exported it from an Oracle database or MySQL or SQL Server and didn't check the export settings and they're left over from 10 years prior? All of those things matter. And so now we're going to go through and show you some of the results of that and then what we've done about it. And one of the things we've done about this is that we have wanted to take the level of expertise out of the equation, because even with a lot of the newfangled tools that are out in the market, it really requires a business analyst, who, remember, is a business analyst. They chose, because of desire or aptitude or for whatever reason, not to get a computer science degree. So it's not really fair for us to come later and give them some tools at work and say, now you have to know all this detailed technical stuff, even though we just told you that the new enterprise tool is really easy to use. Well, it may be really easy to use to get some sexy graphs on the screen, but that doesn't tell you how to solve your data problem. And it may point you in the direction that says, oh, by the way, that integer field has a bunch of ABCs in it. Okay, well, what are you going to do about it? How did they get there? Should they be there? Who's right? Who's wrong? That's what we're doing here. So what we've done is take all that expertise that we built up through many years of consulting, solving these problems, dealing with the technology end to end, dealing with the business groups themselves, listening to the business analysts themselves, and putting that together into something we wanted to really be just a handful of buttons that you click, and then you get the answer. But we also are going to give you one extra feature, is that we noticed, particularly with the business analysts, let's say you did figure out the problems, you then had to stop, have a bunch of meetings, communicate that, mostly to people who don't believe you, so then you have to go around and around on that, and then you have to engage the IT department and the data engineers to go to different tools to start doing data integration and data transformation. And you have to explain to those highly technical people what's wrong. And you can tell them, hey, there's a ABC in my accounting code field and I don't want it there. And they're going to ask you to write out a requirements document. Well, now life just got really unpleasant because you don't want to write a requirements document. So what we've done is take all that and embody this into an expert system. And we tried to make it a simple process that goes through these steps. The various components of that, just so that we have done it, is that the quality guard is how we have automated that. So we're not just trying to provide, hey, here's some statistics, because that doesn't really solve the problem. So what we really wanted to do was to automate the detection, but give you the answers. It's as if you had an expert consulting sitting at your desk and telling you, yes, I've seen that. That is an encoding problem, and it probably happened because someone had an Oracle system on Linux. They moved it over to a Windows system. Somebody else copied it up to a Hadoop cloud system. Then they downloaded it, and through that process, the encoding got messed up, and that's what you're seeing. Well, wouldn't it be nice to have somebody like that sitting right next to you? And then we have to deal with the standards of both semantic analysis, which is what is the meaning of the value, and the structure. Now, the meaning is another type of expert. So take that accounting code. So you have an accounting code, and you have one accounting code, which is 1279. Great, got it. cash outlays for fertilizer. Then you have another one, which is AB 79. And you go, well, what is AB 79? Well, it may not actually exist. And so you need to know that it doesn't exist, but that's semantics. Is that value correct for your business application? It might be correct from someone else's, which then would be the clue as to how it showed up in your data. Maybe somebody else is using that accounting code in a far-flung group that's out in the field, but corporate had recently updated the accounting codes and normalized them to 4 digits, something like that. That's what you have to know. So that's what the kind of things we're looking at. So then the way we do this is that we have embodied this, and we've also really worked to streamline the entire process. So it is really just a handful of things that you have to do. And one of the things that we did when we built up this process is that since we've worked side by side with business analysts for a very long time in large organizations, is we watched how you like to work. We watched what technical details you were comfortable doing. We actually saw the technical details you like to do. We saw whether you wanted to do it in a web page form where you had to click around a lot, or you wanted to do it in a text editor and then upload that file. So we've taken all those lessons learned to heart of what we have seen business analysts from big name companies and big name working as consultants in big name companies, and we put that together as a simplified process. So this is just a short list of the type of expert analysis that's built into the system, and you don't do anything for this. It's not as if you're writing a command file like you're in a standard data integration tool or data quality tool, and you have to specify this. The expert system is doing all this, again, just like you had a world-class expert sitting right next to you. So let's get to some of the fun ones. I bring this one out because Eric always chuckles at it, and I always try to liven his day, is that this is real. And I've seen business analysts become quite properly befuddled when you do this. So you open a spreadsheet, let's say you get a file, open it up in Excel, and this is what you see. And this is an actual example. Now, why does this happen? And what really is bad is when this happens is when the finger pointing starts going on inside the corporation. And it's like, you sent me a bad data file. And it's like, no, we didn't. We have very strict procedures. The data file works. I'll check it. I'll open it on my system. It looks fine. No, you got to send me a new one. Okay, so you get a new one. Exact same thing happens. It has to be on the network. Somebody has the idea it's on the network. Okay, so let's go get the network engineers and check our network. Okay, a week and a half later, because they're busy, you end up with the exact same situation. So it's not the network. Okay, let's go get the database engineers involved. Okay, another week and a half later, because they're busy, it's like, okay, now it's the same type of thing. And now you go get the specialists in the CIO group to go, okay, let's go do some data engineering, and they're going to put it through some streaming tools, and they're going to put it through some data science tools, and they're going to do some R analysis, and that takes 2.5 weeks because they're really, really busy. And then they come back, I don't see a problem, can't tell you what the issue is. Well, here's exactly what the problem is, and here's how you start to delineate it. On the bottom of this screen, you're looking at the binary character view of the source data, and the issue is those first 2 characters that you see there, which are in hexadecimal format. Those are FF and FE. That's your clue, but you have to know that. That's the signature of what's called a byte order mark. And the byte order mark, which is shown in the upper right, comes from the actual Apache Commons IO definitions here, is inserted so that file parsers can automatically detect the encoding, whether it's UTF-8, UTF-16 big endian, or UTF-16 little endian. And then the order changes, and even the presence might change. That's what's causing this problem. That typically happens when you go across the multiple systems. So it may be okay in one system, then it gets transferred to another, downloaded, uploaded, moved around, and the systems are supposed to keep this in order, but what happens is that it can really get messed up, and you don't see it. If you open this file in any standard text editor or even Microsoft Word or anything else, you will not see those binary characters. They're invisible. So you have to know to look for them, and you have to know to look for them in a particular way. So the next one, which we also pick on Microsoft Excel, just because it's very common, and this one is extremely common, and we have seen this innumerable times, and it's caused a lot of consternation inside of organizations, is that on the top is an as-is typed in simple set of data. Now, what we typed in, if you look at cell B4, you see it says 12 in that cell. What we actually typed was 0012. If you look at cell C5, you see it's in an exponential notation given by the E plus 19. That's not what we typed in. Not what we typed in at all. And in fact, we didn't do anything special, which is why in that screenshot you see in the upper right that it's in general format. That's the default format for Microsoft Excel. So all we've done is open it, used it as it does, and this is what you see. So Microsoft Excel does that. On the bottom, go to the cell C3, we highlight the cell, and now in the function bar, you see the actual value. And notice that the actual value has 2 decimal places, 0.01. So they're not being shown in the sheet. Now we'll come back to the issue that I'm sure you're all thinking, well, is this just a display issue that Microsoft Excel is just showing it and that has decided not to show me the decimals, or is this really a corruption of the data? So we'll answer that in just one moment. Here are some of the other ones, and now we're looking at cell C5, which has the exponential E plus 19, and you see in the function bar, that's just a long integer. That's all that is, and it switched it over to exponential format, and then the one just below it, which is E plus 12, well, that is actually a real number because it has decimal places. So now we have a bigger issue. So it's converted to display, but we also have the potential for lost precision. So if you're doing, let's say, national economy analysis, then that E plus 12, that size, is a real number. You have numbers that large. And now you're trying to do an aggregated sum in order to do audit accounting, let's say at your national economy level, whatever country you're in or whatever type of analysis you're trying to do, and you can't have that massive loss of precision. That's just not acceptable. So what really happened? So now what we do is you say, okay, well, if it was just a display, I can live with that. So let's go export it, and then everything will be fine. I'll export it, I'll go bring it into an actual full-blown analytic tool, and then I'll make my graphs, and I'll be on my way. So almost everybody exports the comma separated variable, so that's all we did. And here you're seeing the actual output for Microsoft Excel, and lo and behold, it exported it exactly as you saw it on the sheet. It did not revert back to the actual values. So you see 12 in line 4, item 3, comma 12. So now what we just talked about before, so if those are supposed to be 4-digit accounting codes, and that's common, is to have a very structured syntax for accounting codes, then 12 is not the same thing as 0012. And that is going to seriously disrupt all of the accounting applications and all the analytics that come on. Now, the bigger issue is those 2 exponentials, because now we've lost precision. Those are not the numbers that we need. So now we don't even have the actual numbers. So this is actual corrupted data. So you went from getting a data file, doing the right thing, which is opening in Excel so you can get a view of it and do some initial analysis, exactly the right thing to do for a business analyst. And I've seen younger business analysts start to kind of get nervous and upset at this point because they want to do a great job and they naturally question whether they've done something wrong. Well, what is it that you don't want to do when you're a 23, 24-year-old business analyst is go up to your boss and say, I can't even import something in Excel without corrupting the data. That's not what you want to do, and then immediately follow up with, do you have a sense of what my annual bonus is going to be at this point in time? So those are not the juxtaposition of the 2 sentences you want. So what we want to do is to say, this is not your fault. This is Excel doing this. And then two, that we have a way to automatically detect and do this. And I see that somebody says, stay away from Excel. Here's a interesting tidbit from that. So I'm a highly technical person, and I believe in systems requirements and enterprise architecture and structured engineering and rules and all that type of stuff. So we went into this very large program, which had hundreds of business analysts, and we dictated, it wasn't just me, I'm a consultant, so it was the client and everybody else who technically oriented, and we had all these meetings, and we dictated that the business analyst, thou shalt not use Excel, because this will happen. So then you come back into the cubicles, the quaint time when there were cubicles, remember those days? And then we would see it, and what was every single business analyst doing? Working in Microsoft Excel, every single one. And then you would say, you're not supposed to do that, and they would hurriedly turn it off. Come back a few hours later, every single business analyst is working in Microsoft Excel. And then you say something like, well, you realize the organization just spent $4 million to get an enterprise license for major fad tool A, and it does everything imaginable. So why aren't you using $4 million enterprise tool? Because I don't understand it. They don't give me a developer's license, so I have to call the data engineer to do my job, and I know how to use Microsoft Excel. And you know what? Those are real reasons. So when I heard that, I said, go ahead, use Excel. But now let's train you on what to look for in Excel. So here is a sample source file that we made. Now this is real data. This is actually IRS migration data. You can get off the IRS site. So the IRS, as part of their census analysis, publishes data about how people are migrating through the US, and they include not just numbers, but they include it by ethnic breakdown, and they also include it by income breakdown. So you can see where the high income and low income people are moving around all the time. So I took that, and then I did make some manual modifications just so it was a good sample file. But these are all the type of errors that I have seen innumerable times. In fact, I will tell you that if I went into a large organization, I'm going to just rule of thumb, I will see these errors. It's an 80% likelihood that I will see all these errors. It's a 95% likelihood that the teams of very good people from all the different groups, the business analysts, the enterprise architecture, the data engineering, will not have even thought about these problems to date. And they will probably have spent 3 to 4 months meeting and going back and forth by that time. So yeah, I like to pat on the back as I come in and go, yep, here's your problem. Here's my bill, see you later. But the real issue is that we want to make this something that you can do. So these are real world problems. And look down the lines. Line 24 and 25 expose the embedded delimiter. So between the word migration and foreign is a comma, and this is a comma delimited file, but only line 25 is quoted. So that means on line 24, that comma indicates that it actually is another field. So the parser will see that. Lines 27 through 30 expose something, 26 through 30, that is very real and people don't see, is that these single records will be broken across many lines in the file. And that happens because older web systems would allow users to type in line feeds, and that would get embedded in the database. Database engineers don't think about it, so when they give you an export, those fields have line feeds in them, and then you're just ready to go. This is how they get parsed. So that first one on the left parses into 8 fields, but it's not supposed to have 8 fields. It's supposed to have 7. And on the right-hand side is what it looks like it's fixed. And the point I want to make is our expert system fixes it automatically. So this is all part of what we have built in with the expertise so that you don't have to become that technical expert. Then we get to a full report, and I'm only going to show you some examples of that report. So what this is showing in this particular sample case is that the number of lines that did not have error, and because I created the sample file, the answer was 0. But on the right-hand side, it shows what percentage of those erroneous lines can be corrected automatically. And then just using the built-in quality guard algorithms, it's 100%. Then it also shows you the type of errors. So we had formatting errors. And again, we did that on purpose because you could specify the required format. So one of the reasons there were so many errors is in that the dollar figure in this record, we declared it to be require 2 decimal points, and none of them had 2 decimal points. So that throws a format error. But we also had 9 data type errors where we're using, again, an expert way of detecting if you say it's supposed to be a real number, an integer number, one of many different kind of date formats, what's going on. And the fields number shown there is when the parsing generates the wrong number of fields. On the right-hand side, it gives you a lot of statistics about the data. There's lots of tools that give you stats. So there's nothing special there. What this does as an expert system, it gives you a little bit more information so that you can then infer whether or not the semantics are correct. Because remember, that's what we have to be after. Almost no tool that you have access to in your enterprise addresses the semantics of your values. So we get at that by saying, for example, the AGI. This is the percentage of unique values over all the fields. Okay, 96% of all the numbers are unique. I expect that from a dollar value, right? Don't expect many common. But now let's look at the Y1 state name. There's 14% that are unique. But now I look at Y1 state, only 5% are unique. So that's a mismatch because the Y1 state should be correlated to the Y1 state name. So now you have an indicator that you have a semantic issue going on. Now we give you the values. So again, but that's pretty much plain vanilla data quality analysis. The point here is you now have a reason to go look at them. And then finally, some of the details that come in to make it kind of obvious. And then I just want to call your attention to the right-hand side, which is the settings. And when you set up to run the job here, that's pretty much all you set. It's really one simple form of 6 to 7, maybe 8 optional settings that you make. You run the job and you're done. And that's all part of us trying to package up human expertise so that you can keep going and not be bogged down with that. And then finally, a couple of button-oriented things so that we automatically create a corrected file. And that's kind of a non-trivial thing. So in most systems, once you figure out what's wrong, you then have to engage the data engineers for weeks of work in order to try to get a fix. The corrected file is made in real time. You get it immediately when the job is done. And then that is also we allow some simple, it's not a complex system. You can define formatting and you can even define some simple value transformation like prepending a $sign. And you're seeing that here. And the only thing else I'll call to your attention, because business analysts that I had worked with wanted this, if on the right-hand side, the third line down, you see dash, not int dash. That was a very good idea by some of the business analysts for them to be able to flag accounting style problems when they went further on and they started doing accounting audits. So that was a red flag that they wanted for the auditors. And I thought that was a very good idea, and that's an idea I were to come up with on my own. So we allow you to do that through a transformation. And that is where I will stop.
Yeah, that's right. Well, folks, we burned through an hour here. It's always fun with Dr. M. And you see Bob Garrity up there, who's also part of the team here. I'm very excited about this. I'm very excited to help people solve intractable problems because, again, this is blocking and tackling stuff. This is basics. To make a football analogy, if your offensive line isn't worth much, your quarterback's going to get sacked, and you are the quarterback, basically. So in your data science world, in your data management world, whatever you're trying to do, of data you're trying to load and use and leverage, well, if you can't get the file to work properly, that's like step one. I mean, that's ground zero, basically. So look this stuff up online. Technic Analytics is the name of the company, but we have your email. We'll email you some data so you can check this out. Data Star NG is what it's called. And check it out, folks. We're going to have some fun. We'll finally be able to solve these old problems. Big thanks to you, Dr. M. Big thanks to Bob Garrity. We'll talk to you all next time, folks. Take care. Bye-bye.